Characterizing Spatio-Temporal Moments. Part 1. A Critique of Pure Science. What is science? This is a highly dense presentation. Feel free to pause at any time to consider the notes above. Basically, all science begins with noticing some phenomena. Scientific inquiry typically ends when a phenomena is well understood. Generally, the scientific process passes through a series of steps or phases. These begin with discovery and end with common understanding. Science is really good at things everyone can agree on. Such things stand out, among other things, less obvious. Subtle things are a bit more of a challenge for science. Specialization in science helps bring things to focus. You have to know a lot of background stuff to succeed as a specialist. Specialists rely on a lot of related specialized knowledge and techniques. Then go on from there. You got to go through a lot of organized training to be recognized as a scientist. To be an unrecognized scientist, you got to learn to pay attention and explain things logically to yourself. Does anything about what I'm about to say make sense to you? Science has a problem with making connections between different things when it's science at its worst. Science can compare and science can contrast, but only among tangible observables. Comparing and contrasting requires a lot of detailed information. Newton is said to have seen an apple fall from a tree. He compared and contrasted the beginning and end state of that apple. Generalizing on other such experiences, Isaac came up with the idea of universal gravitation. But Isaac Newton was a generalist, not a specialist. Anyone can do science without being a scientist. You start with paying attention to things and end up with coming up with a good explanation for it. You could be wrong, though. That's when other scientists get involved. As long as you're willing to be wrong, good work is possible. Emotions and ego only complicate the process. Be prepared to be wrong. You'll always learn something anyway. And stick with it. In his time, Isaac Newton did cutting-edge science. Who can do bleeding-edge science? But he was not quite right. Leibniz proved him wrong, and Einstein had to fix things. Newton treated gravity as point source. Gravity is an influence coming collectively from every tiny particle of matter. We simplify gravity's effect by summarizing all sources into a central location. Einstein saw gravity as something other than a force. For him, it meant space and time. If you want to do bleeding-edge science, you might have to prove Einstein wrong. In proving Einstein wrong, you might even come up with a better explanation for gravity. Physics has one fundamental problem to solve today. The problem has to do with how one remote cosmic event created everything. That event, the Big Bang, is said to have happened before space-time ever existed. The Big Bang created everything, time and space itself. Yet the Big Bang is not posited to have a predisposing creator or creative cause. Meanwhile, a host of secondary mysteries also remain unsolved. Those mysteries involve effects that don't seem to ever run out of gas. Such secondary influences are called forces. The summer of 1887 saw two scientists do an experiment to see if space was like an ocean. The two scientists, Albert Michelson and Edward Morley, put interferometry to the test. Interferometry can be used to detect a phase shift in light based on right angles. Had space been oceanic, that luminiferous ether, a shift would have been seen. The Earth's motion around the Sun did not cause a shift in Jupiter's light. Yet perhaps a luminiferous ether may have little to do with being oceanic at all. The experiment later resulted in Albert A. Einstein's general theory of relativity. His general theory has now severely tied us to our home planet Earth. What if Einstein is right? If Einstein's theory of gravity is true, then space itself is curved. If space is curved, what causes that curvation? If something causes curvation, what other effects might it have? Meanwhile, Albert also posited an upper speed limit to all things made of matter. If an upper speed limit exists, where do we go from here? Is there any escape from Einstein's paradigmatic bottleneck? Maybe, maybe not. If you look at the question, as always has an answer, and see if you can get an answer. Those answering A assume that they don't know. That's a good place to start. Those answering B make an assumption science will never resolve that particular question. Those answering C need only read out on a general interest in science. Those answering D express an ongoing interest in researching any given scientific question for themselves. Those answering E have fully vested themselves in a problem that has captured their imagination. The problem now before us is whether or not we can ever travel between the stars using conventional methods. To do so, we should investigate the nature of space and of time. Part 2, the fabric of space-time. What is the question answer here? If Einstein's universal mass increases with speed, ultimately mass becomes infinite at the speed of light, c. When mass becomes infinite, no more acceleration is possible. Meanwhile, all physical and biological processes stall due to a lack of activation energy. Effectively, the equation E equals mc squared tells us that E approaches 0 and m approaches infinity. Einstein's hypothesis has now been repeatedly proven by experimentation. We might assume that Einstein's relativistic limit only applies to matter. Yet were we to become light itself, we could only travel at some 300,000/183,286 miles per hour. In positing the existence of spatio-temporal moments, we hit the same upper speed limit. In fact, STMs do not actually move at all, they merely oscillate in 3 dimensions. However, once entangled with others, STMs become matter and can relocate in time and space. Effectively, persistently entangled STMs are no longer part of the light-propagating picture. Materialized STMs can now rely on 2 main factors for mobility, radiation pressure and gravity. These 2 factors are now the dominant factors in the cosmos regarding stellar evolution. Meanwhile, significant changes in spatio-temporal behavior are also seen on atomic and molecular levels. Sadly, nothing about STMs suggests their ability to support faster than light travel. Like string theory, STMs do manage to integrate all forces of nature. The intranuclear force can be thought of as the natural consequence of superabundant energetic entanglement. Meanwhile, in highly condensed nuclei, gravitation too plays a role in sustaining transuranian elements. The weak force can be seen as a means to prevent incursion of electrons into atomic nuclei. The electromagnetic force can be seen as a means to block energetic stimuli from neighboring moments. Gravity, like electromagnetism, is native to all STMs. It helps them keep in touch with one another. STMs, unlike the fundamental elements of string theory, do not make anything possible. STMs require a transcendental factor to explain their activation. STMs are predicated to have existed before the Big Bang. Before the Big Bang, they remained quiescent. We can assume neighboring spatial moments, non-temporal, maintain contact with each other. Contact between spatial moments did not involve any oscillatory behaviors. Neighboring spatial moments then become string-like, but still connected to other SMs. It can be said that in transiting to SMs, STMs participated in entropy. Entropic ST moments gradually lose entanglement with others as energetic stimuli languish. Complex living organisms decay, molecules break down in atoms, and atoms into subatomic particles. ST moments then oscillate at normative rates until the universal energetic component equilibrates. Once all particles disentangle, time, as we know it, comes to an end. Today's measure of the cosmic microwave background radiation illuminates this process. The CMBR remains one of the finest phenomena available today to see STMs in native form. Meanwhile, we might predict that all material substance in our cosmos will eventually decay. However, the presence of both dark matter and energy in the cosmos suggests this will be a long time in the coming. Sanskrit philosophy gives us clues to how the universe came into being. The term Maha Manvantara describes cosmic manifestation and Mahapralaya, where it ends. So this final segment here is a summation of everything that's already been expressed. Basically, you might want to pause and look through it and see if any of it makes sense to you. I pretty much threw this together on the fly after having introduced a video where I've illustrated what STMs might possibly look like. STMs themselves, spatio-temporal moments, might be considered the essential building blocks of all things material and the vehicles through which photons are passed one to the next, but only after the STMs have been energized by more remote operations. Thanks for watching Characterizing Spatio-Temporal Moments. This has been an ad-lib production for the Golden Phoenix Published YouTube channel. It features potential insights into the next step forward in resolving the mystery of the cosmos. The text and music is by myself. Thanks for watching and giving it thought.